Hi everyone, welcome to part 4 of lecture 3. So far we have discovered the random variables, PMF of them, the probability mass function, and then we have covered the cumulative distribution function. So the PMF of a random variable x provide us with several numbers, right? And all possible values and their respective probabilities. So you remember from the rolling a die example. But let's say I want to summarize this information in a single representative number. So as you remember, instead of using several numbers, I just want to use one single number to get some useful information about the random variables. So if this is the case, I can use the expectation of x, and this is called a weighted average of all possibilities. So the formal definition of the expectation, the expected value, or also we can call it the mean of a random variable x with PMF px, p subscribed as, is expected of x is equal to the sum of the real values multiplied by corresponding probabilities. And also sometimes we illustrate the expected of x by using the Greek letter mu. So before jumping into the details of the expected value, I just want to clarify the weighted average. So what is the weighted average? Let me give you a solid example. Imagine that you will calculate your grades after the midterm and final exam, and let's say your final exam will affect your final grades by, let's say, 60%, and your midterm will affect 40%. And let's say you got 80 in final, okay, and this is a midterm, and let's say you got 60. So when you are calculating your averages, your average, what you are doing something like that, right? So multiplied by 80 plus times 60. So these things is your grades, and these two, the weights of exams. So this is the basic and the main logic behind the weighted average of some values, right? So, and here we are doing the same thing. So we can open this one is by x1 times px1 plus x2 times px2, etc. So actually we are doing the same thing as we did here. So we are simply calculating the weighted average of the x, and this is called the expected value or expectation, or the mean of the random variable x. So here they consider two independent coin tosses, and each with a 3 or 4 probability of a head. So this is not a fair coin, So let x be the number of heads obtained, and what is the expected value of x? So to calculate the expected value of x, first we should compute the PMF, the probability mass function of this experiment. And let's say what is our interest here is the number of heads, right? So this is a 2 coin, and I can get head, 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 tail, tail, head, and tail, tail. So I can get 0 heads, 1 head, 1 hat and 2 hat. So if x is equal to 0, this is corresponds to this subset, right? And the probability of this subset is simply 1 over 4 times 1 over 4, right? This is the probability of getting tails for the first coin, and this is the probability of getting tails for the second coin. Because these are the independent events, we can simply multiply these two distinct probability. So that's why the probability of x is equal to 0 is 1 over 4 squared. And let's look at this one. So in this case, if x is equal to 1, so I have two subsets and I need to calculate the probability of each subset. Let's first calculate this one. In this one, getting the probability of tail is 1 over 4 times getting the probability of hat, which is the 3 over 4. So, and this is the first one, and the second one is same actually in this case, which is 3 over 4 times 1 over 4, getting the probability of hat and getting the probability of tail. So I can simply write this one as 2 times 1 over 4 times 3 over 4. So this is the probability if x is equal to 1. And the last one is getting 2 hat. In this case, x is equal to 2, and this corresponds to this subset. So it's simply 3 over 4 times 3 over 4. So this is a 3 over 4 square. So these are the PMF. And remember the definition of the expected value, the summation of the values times their corresponding probability. So in this case, the first x, this one, the x1, okay, this one, and the probability of this is 1 over 4 times 1 over 4 square, and plus this x times this probability, and the plus 2 times this probability. So at the end, I will get the value of 302, so which is 1.5. That's mean my expected value of this experiment is 1.5. Okay, so this is the expected value, and also you can call this as the minimum of this experiment. So if we want to summarize these results by words, I can say that at the end of this experiment, I will obtain 1.5 hats as an average. Okay, this is the interpretation or summarizing this experiment by a single number. So that's why we can say that the x is a representation of the random variables, and this is a just single the mu x is just a single number, and the single number is a representative value of my random variables. This expected value of x will be somewhere in the middle of the range of possible values. So this is inherently true, right? Because let's say you will get the values, you will get the minimum of the values which are ranging between a and b. So the mean of these values cannot be less than a, or they cannot be greater than b, right? So that's why it will be in somewhere in the middle of this range. And same thing valid for the expected value of the x. And this expected value can be the center of the gravity of the PMF. I mean, let me give you an example from a physical system. Let's say I have something like that, and this is the balance point. So when I put some weights like here, remember from your high school lectures, if I put these weights to the correct places, they will not go down from both sides, right? So this is the center point. and the expected value can be think like that. It's a center point, and it's a balance point of the PMF. And the last thing is, if we run if we do a long run experiment, the average of the probability of that expected value will be equal to 1. So if the limit when the n goes to the infinity, the expected value x will be equal to the limit of the sum of the xn divided by n. So this is the average of the x's while n reaches to the infinity. So it's going to be equal to 1. Okay, this is another property of the expected value. So another one is the expectation of functions of a random variable. So let x be a random variable with PMF, the px, and let g of x be a function of x. So that's what's that meaning? So we assign some x's, right, in previous example, like x is 0, x is 1, x is 2. In this case, we will define the x's based on some function. Okay, let's say xi and g of xi. So in this case, the expected value of that function, and this function actually produces the random variables, will be equal to sum of the g of x times p of x. Okay, so the g of x, the function of x, times the PMF of x. So keep this in mind. Okay, now we can verify that equality, and to do this, let's say the y is equal to g of x, and we can use the definition to calculate its expected value, right? So how we can do that? So the expected value of g of x is equal to the expected value of y, right? Because g of x is equal to y. Yeah. So, and from the definition, this is a random variable, and that's mean we can calculate the expected value or weighted average, or the expectation by using the definition. We can calculate it, right? And how we can do that, which is a summation of y times PMF of y, right? So we rewrite this part. So now, because this is a constant value, we can just it can go outside of the summation here, and also we can rewrite this part as this one. So how we can write how can we rewrite this part as this way? So to make it more concrete, let me show you visually. So let's say we have some y values, okay, y1 and y2. So where these y's comes from? Actually, they depends on the values of the x, right? So let me change the color, and let's say I have x1, x2, and x3. So remember that the y is the function of x, right? And the x1, let's say x1 and x2 are giving the same y value. So g of x1 is equal to g of x2, and x3 gives us the y2. And let's say the probability of x1 is a, and the probability of x2 is b, and the probability of x3 is c. So in this case, we can say that the a times x1 plus the b times x2 is actually the y1 plus a plus b, right? So so this is the equal, right? So a times x1 plus b times x2. Actually, this is the expected value of x1, the expected value of x2, and this is the total probability of these two events, and this is the random variable of y1. So now let's open this part. Okay, let's say we have three events like x1, x2, and x3. What is this part? This part is actually p1, sorry, px1 and plus px2 and plus px3, right? And let's add the let's multiply with the y each term. So for x1, what we said it will give us y1, right? So this is going to be y1. So for x2, it's again will give us the y1. So I will multiply this with y1, and for x3 it's going to be y2, right? y2. So what was the probability of this one, which is a, right, from here, and this is b, and this is the c. So here will be a times x1 plus a times y1 plus b times y1 and plus the c times y3, right? So what is this part, which is a1 plus a plus b, and this is y3c, right? So what is this? Actually, this is the probability of y1, right? And this is the probability of y3. If I write this as a PMF, so I can say the P y is equal to a plus b if y is equal to y1, and c if y is equal to y3. So this is going to be y2. Actually, I did that wrong way. So and this is y2. So this is the PMF of P of y, right? So with this one, actually we got this one. So I can say that this part is equal to this one. Okay, so instead of using this one, I can rewrite the PMF of y as this one. So now my my formulation is now like that: the sum of y and sum of g such that g of x is equal to y, and y times PMF of x. So y is went to the inside again. Now this y is equal to g of x, right? We know that it is given to us. So that's why we can rewrite this part as g of x times p of x. So and then now I have two summation, but there is an interesting point here. Let's say I will do some loop in here, right? So let's say I have two y1 values, 1 and 2, and this corresponds to x1 and x2, and this corresponds to x3. So the first thing here, I will assign a value as 1 to y, which is 1, and I will look at every single elements of x. So these are going to be x1, right? So which will be x1 plus x2, And in the second step, I will change the value of y as 2, and I will look at the corresponding x value, which is x3. So what I did here actually, I searched, I look at every single elements of x, right? So basically I can cancel this one and I rewrite this part as this one, right? Because if I use this part, that's mean I will look at every single elements of x, and this is actually what I did here. So I can only come up with this formulation. Okay, so as a summary, if the random variables is a function, and I can rewrite this formulation as this one, g of x times PMF of x will give us the expected value of that random variable. And that random variable based on a function. So let me give you an example here. Let's consider a discrete random variable x with the following PMF. So this is the PMF of x, okay? And what is the expected value of x squared? So here, the random variable is based on a function, right? And we are looking the expected value of some function. And let's say this is g of x. So let's do it in a simple way. And what we look for, we are looking for this one, right? Expected of x squared. So what I can do here, what we said, we can use directly the g of x. So what is the g of x? Is a x squared, right? So this is a actually this part is g of x1 times p x1, this part, and this part is g of x2 times p of x2, this part is g of x3 and times p of x3. So and that's why what is the square root of the x1 is 1, so x1 squared times what is the corresponding probability is 1 over 4. And for the x2, what was the x2 is 0, and g of x is 0 squared, because the x2 is 0 and corresponding probability is 1 over 4. And the last one is x3, which is a 1 and 1 squared times corresponding probability. So that will give us 3 over 4. So if we compute in a long way, first we have to calculate the PMF of y, and y is equal to x squared. So what was the x? Let me write here. 1 over 4 if x is equal to minus 1, and I think 1 over 4, yes, 1 over 4 if x is equal to 0, and 1 over 2 if x is equal to 1. So so first let's calculate the random variable of y. So y, let's say this is the y column, and y is equal to x squared, and this is going to be 1, this is going to be 0, and this is going to be 1. So how many different values I have now? 2, right? 0 and 1. So let's write the PMF of y. I have two values, 0 and 1. So what is the corresponding probability? First, let's start with the 0, if y is equal to 0. So I have only one probability, right? Which is 1 over 4. And for the y is equal to 1, I have 1 over 4 plus 1 over 2, and that will give us 3 over 4. These are the independent of x. So so this corresponding probability will be 3 over 4. And then I can I can calculate the expected value of y. How? Let me open this one, which is actually the sum of y times p of y, right? So if I open this one, actually this means y times probability of y1 plus y2 times, let's clear this one. This is a y2 probability of y2 and y3 probability of y3. Okay, and there is no y3 actually, sorry. So actually this is what I did here, right? This is y1 and this is y2, and this two guys are the corresponding probability. So the result is 3 or 4. So this is actually what we did here, the same result. Okay, so so based on your personal choice, you can use this formulation or this one, right? Whatever you like. Okay, another term we will cover is the variance. So if I ask you what is my expected error if I summarize the entire distribution in just a single number and how they related with the mu of x. So this is a mean, if you remember. This is a mean. And I can ask this question from different way, and I can ask how variable is x. So what is the variability of x? So to make it more clear, let me show you something. Let's say I have some numbers and this points corresponds to the mean of all these points. Okay, and I want to calculate how these points far from this mean, the mean of all the samples. So for example, this points far from the mu as this one and this one like that one. So how can I calculate this one? The calculation methods of this variability gives us the variance, and the variance of a random variable x, so x can get different values, as follows. The variance of the x is the expected value of x minus expected value of x squared, and this is also shown as the sigma squared x. So this is the variance. So the variance is always non-negative. Why? Because here we will get the square root of the x minus expected value of x, right? And this makes sense because, for example, if we don't take this square, some distance will cancel each other, right? Because here, this point, like let's say A, and let's say this is the B, A minus the mu is a positive value, and B minus mu is a negative value. So these two things can cancel each other. That's why we squared them. So you can calculate the variance of the random variables with two different ways. First, let's look at the first one, and we will visit the second one in future. So the variance of x is simply the expected value of x minus expected value of x squared, and this is equal to the sum of the x minus expected value of x squared times corresponding probability for each x. So the square root of the variance is called the standard deviation and denoted by the sigma. Okay, the sigma x means the standard deviation of the random variables x. Okay, now let's look at some properties of the mean and variance. And to do this, let's start with a random variable x and define a new random variable, which is y, and that y is function of x, and the y is equal to a times x plus b. So how we can calculate the expected value of y? The expected value of y from the definition, the y times pxx, right? And this y is actually g of x. This is a function of x. And what is y? Which is a times x plus b times corresponding probability. So let's distribute this one, and this will be sum of x ax times p of x, pmf of x, plus right plus b times pmf of x. So because this there's a plus sign here, we can do it with two different summation, and it will be actual sum of a times times x times pmf of x plus sum of b times probability of pmf of x, right? So, and then because this a and b is the constant values, they can go outside of the summation, and this part will be this one, the summation of x times pmf of x plus b summation of b times summation of the pmf of x. So what is this part? This part is expected value of x, right? Remember, and if you are not clear in that point, please check the definition of the expected value of x from the previous slides. So this part becomes a times expected value of x plus b, and yb, this is the total probability, right? And remember the first axioms of the probabilities. The probability of omega is equal to 1. So actually this is the sum of the probability of each events. So that's why this is equal to 1. And the final results will be a times expected value of x plus b. So that's mean I can calculate the expected value of g of x as an a times expected value x times b, right? And we can conclude that the expectation is a linear operator. So as a result, the expected value of g of x, and it is defined as y in our example, is the a times expected value of x plus b. And what I mean, we just change the x in the main form in main function with expected of it. Okay, and also we can say that the expectation operator is a linear operator. So this is the first formulation we will use in future studies. Please keep this in mind, okay? Keep this in mind. So, okay, now let's look at the variance, and we will have the same example, which is the y is equal to a times x plus b, and how we can calculate the variance. So, from the definition, let's look at the definition, and the variance is x minus expected value of x, x squared times pmf of x, right? Which is the variance of the random variable x. So simply this is my random variable, and this is the expected value of my random variable, and squared. So this satisfies the definition of the variance, right? So I can rewrite this part. This is the expected of y, and y is the function of x, as this one, right? This one we did in the previous slide. a time expected value of x plus b actually equal to expected value of y. Okay, so this part is expected value of y, so I can rewrite this one a times expected value of x minus b. So this two terms cancel each other, and the a squared can go outside the summation because it's constant, and I will get this one, right? This one. Sorry. Let me do it smoothly. Okay. So I will get this part. So let me check this one. What is this part? Actually, this part is x minus expected value of x squared and times PMF of x. What was that? That is the variance of the x. So this part is actually the variance of x. So the variance of y is actually the a squared times the variance of x. So what I did, I got the square of the x's constant value, and also I exchange x with the variance of x, and I just canceled the b. So this constant value, the b, doesn't affect the variance. Okay, so this is the another property, and we will use this property in future studies as well. So if you remember, I said that there is another way to calculate the variance, and now let's look at this one. So which is the x? This is the definition of the variance, right? X minus expected value of x squared times PMF of x. So let's open this part, which is the x squared minus 2 times x times expected value of x plus expected value of x squared. Okay, so and let's make the multiplication, and from this multiplication, it will be sum of x squared times PMF of x minus 2 expected value of x, right, and summation of x times PMF of x, right, and plus expected value of x squared times summation of PMF of x. So let me write this one. I just simply write this one like, okay, let's open this part. X equal to x squared, and this is the term we will use, x minus 2x expected value of x times of x, and plus the expected value of x squared times PMF of x, right? So I can separate that summation, so, and I can write in this way, right? This way. So what is this part? This is actually the expected value of x squared, right? So and you can think this x squared is the g of x. And what is this part? This part. This is the expected value of x. Look at the definition, okay? So 2 times expected value of x times expected value of x, so it will be equal to 2 times expected value of x squared. And what is this point? This is a total probability, the probability of omega actually, and this is equal to 1. So let's cancel that one, and it's going to be expected value of x squared. So this will be the expected value of x squared minus expected value of x squared. Okay, so this is another formulation, and which one you like, you can use either of them. So it's based on your personal choice, but both of them will give you the same result. Okay, so in summary, we have two important equalities. The first one, the expected value of a times x plus b is equal to a times expected value of x plus b. The second one is the variance of a times x plus b is equal to a squared variance of x. And the last one is the variance of x also can be calculated by expected value of x squared minus expected value of x squared. Okay, so these are three important formulations we will use through the semester for this class. Okay, so let's look at an example. In this example, if the weather is good, which happens with the probability of 0.6, the Alice walks 2 kilometers to class at the speed of 5 kilometers per hour. Okay, so this is my first actual random variable. And the otherwise, the rides her motorcycle at the speed of 30 kilometers per hour. So let's say, what is the mean of the time t to get to the class, and what is the variance of t? Another question is, what is the mean of value of v, the speed, and what is the variance of v? So let's first start with the t. The first, we have to compute the PMF of t, right? So we have two options, the whether would be good or not. So the probability is given to us, which is 0.6. And in this case, if t is 2 over 5 hours, that means the weather is good, right? So which is the probability. So if t is equal to 2 over 30 hours, in that case, the weather is bad, and the given probability is 0.4. Okay, so how we can calculate the expected value of t? Simply, we can sum the multiplication of the random variables and the corresponding probabilities. So in this case, the 0.6 times 2 over 5 plus 0.4 times 2 over 30 hours. So it will give us 4 or 15 hours. So this is the expected time from this example. And let's calculate the expected value of speed, so the v. So in this case, we have actually the same probabilities. If the probability is 0.6, that means our speed is 5. Okay. And if the probability is 0.4, that means actually our speed is 30. And it will give us the expected value of our speed is 15 kilometers per hour. So there is interesting here. There is interesting. Okay, there is something important here. This is the general formulation of the time, right? The time is total distance. This is given to us in question, divided by the speed. And we find that the 4 over 15 is the expected value of t, right? Here we find that. So instead of t, if I write 2 over v, so expected value of 2 over v, which is equal to 4 over 15, right? And what if I ask you, if I write this one as expected value, 2 over expected value of v. I mean, like that one. So if you would do that, you will be wrong, okay? Because the results of this one is actually 2 over 15, and which is not equal to 4 over 15. So what can I conclude from this result? So I can conclude that the expected operator cannot be distributed in a multiplication and a division operation, but you can distribute it in an addition and subtraction operation. Okay, so that's why these two things are not equal to each other. The results will be changed if you distribute the expected operator. So this is the important thing we have to remember. Now let's look at the solution for the variance in same example. The first one we have to calculate for the time, right? And what was the formulation of the variance of t in this case? The expected value of t squared and expected value of t squared. Okay, so let's first calculate this one, so which is the expected value of t squared. So these are the given probabilities, and these are the corresponding random variables. We just squared them. So at the end we get the 22 divided by 225 hours. So hours squared. So we calculated this one here, okay, and what is this one? We actually calculated here, which is 4 over 15 hours, and this will give us 2 over 75. So for the v1, for the speed, let's first calculate the expected value of v squared, and the same thing, this is given probabilities, and these are the given the random variables for the speed, and we just squared them, and we got 275 kilometers, 375 kilometers per hour. So we can simply calculate the variance of the speed by using the same formulation, and it will give us 150 kilometers. So the variance of the speed is 150 kilometers, and variance of the time is 2 or 75 hours. And also we calculated the expected value of t and expected value of v, the speed. So in this lecture, in this part, we have calculated the variance and the mean. So we are done with this part, and if you want to make some extra practice, please check the questions in book chapter, and I'll see you in next lecture.